feel so bad because I found out that you guys had a test.
We're still talking about this?
Hey, Lord. I have said it to this class before, but Lord, I appreciate you giving me these 5 young people. It always brightens my day. It makes me happy. Lord, I have 5 very unique children in this class, and I am blessed. It's those small blessings, Lord, that keep us going day to day, keep a smile on our face, and I don't ever want to overlook those small things, God. I know you have big plans for each of these kiddos. You still have big plans for me, and I'm trying to follow your path. God, we do everything, hopefully, the way that you want us to. We continue to strive to be better each day. Lord, we appreciate all that you do. We love you. In Jesus' name, amen. Okay, so the main thing that we can get from yesterday's lesson was how we start to describe 2-dimensional figures. Okay? And we're going to review a little bit of the circles. We're going to be doing that because there are going to be circle questions on your test. I'll do that before we get into solids. So, first off, just by the number of sides, what is this?
Pentagon.
Pentagon, because it has 5 sides. So this is a pentagon. Somebody other than Esther. What does it mean when I have the same number of arcs in each corner? Cooper?
Equal angular.
Yeah, that means all of those arcs are congruent. Congruent means they're exactly the same, which is what equiangular means. So this is an equiangular pentagon. Okay? So again, equiangular, because all of the angles are equal, are the same, they're congruent.
Wait, so the answer is equiangular?
Equiangular pentagon. We're naming the figure. It's an equiangular pentagon because it has 5 sides. That's how we name that. Okay? You'll have questions like this on your test. Okay, number 2. Ella, what's the shape?
A square.
It's not.
Oh, it's
It has 4 sides. What is it? Go to page 33 if you need help with it. I think that was
quadrilateral.
32. It's a quadrilateral. 4 sides of the quadrilateral, and it's not a square, and we're going to learn all about that. So it's definitely a quadrilateral. What do we know about this quadrilateral? Go ahead.
It's equilinear.
It's what?
Equilinear.
Not equilinear.
Equilateral.
Equilateral. Lateral being the sides. All of the sides are, what's that C word? Congruent.
The second one's an equilateral.
Quadrilateral. Yep.
Almost.
And number 3. It's showing that all of the sides are the same. All of the angles are the same. So the first thing, go ahead, Cooper.
Regular octagon.
Regular octagon. Very good, sir. Regular means it's both equilateral and equiangular. And it is a regular octagon. Questions there? Okay. We're going to go over the homework. And then I would like to do a couple. I'm sure there's some that you missed from the homework that I'd like to do on the board. Okay, and if that means, hey, we don't get to the lesson and I have to bump to the test, I'll do that. Like, we're in no rush. Okay? Get your homework out. It was paid.
What hours do you have a class?
First, second, I have planning 3rd and 7th.
Oh, perfect. I didn't finish my homework. Can I bring my homework in Thursday to you?
Yes. There's a class going on in room 112. Just come in, I'll pop out.
Okay.
Okay, so we had pages, I think, 35, 36, or 35 through 37, 13 through 51 onwards. So you're going to show it to me again, okay? The ones we will see. And you already told me that you didn't get yours. Okay. I'm going to put that in right now.
question about number 39.
Here we go. So, number 13, name the sides of the polygon. What is its most specific classification? Well, it's an octagon. Okay, that's all we can say, because we don't know anything else about it. We have segment AB, segment BC, segment CD, segment EF, segment FG, segment GH, and segment HA. Those are all the sides. Okay? Our sides are segments for two-dimensional figures. Everybody with me there? Number 15. Segment XD is a radius. Segment DC is a chord. Remember, radius is from the center to the edge of the circle. A chord is just two endpoints on the circle. C, X is the center. D is the arc, because it's just a portion of the outside edge of the circumference.
AD is the arc, you said.
Yep, because you can even tell when it has that arc over it. Notice how it's not a straight line, it's a curve. That's the arc. And segment BD is the diameter. Well, what else is it? It's also a chord, because diameters are chords, because a chord only has to have two endpoints on the circle. Questions on that? Number 17. The circle is circle C. 19. Name 5 radii. Okay, radii or our multiple radius. Segment CX, segment CA, segment CY, segment CP, segment CT. What do we know about their lengths? They're all the same. Okay, questions on 13 through 19. 21, name 6 triangles. Triangle ABE, triangle ABC, triangle ACD, triangle ADE, triangle ABD, triangle ACE. And these were ones that I showed you on the board yesterday. I helped you with this problem yesterday. Remember that? 23, what side of the largest triangle is opposite of angle B? Opposite of angle B. So, find angle B in your book. Draw your finger away from it all the way to the opposite side. So, move your finger away from it, opposite. So, if I've got a triangle like this, and it's A, B, C. Here's angle B, I go away opposite of it. I draw away from it, that side would be AC. In this picture, it is a segment AE. 25 we did not do. 27 we did not do. 29 we did not do. 31, name 2 points in the exterior. Point G and J. Outside, that's what exterior means. 33, interior. H, I, or J, any of those two. 35, I said skip. 37, perimeter is 35. We add up all the sides. 39, the perimeter is 2A plus 2B, or A plus B plus B. Because those are the sides. You're adding up all the sides. Just show me that. 41 is either C plus 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 C, or you could just put 8C. 8 multiplied by that length. Okay. 43, a regular heptagon. A heptagon is 7 sides. So I take 7 times 28, and I get 196 millimeters. You'll have questions like this as well, because we did the formula, P equals SN, perimeter equals the side length by the number of sides, right? 45. Ooh, the perimeter is 78, equilateral. All the sides are the same, so we take 78 and we divide it by 3, which gives me 26 centimeters. 47, what is the length of each side of a quadrilateral whose perimeter is 36 if opposite pairs of sides have the same lengths and one side is twice as long as its consecutive sides? So, quadrilateral. It says the perimeter is 36, so the whole thing is 36. We have one side, and the other one's 2 times that. So that means we have 2x and x. So that's 4x, 5, 6x. So 36 equals 6x divided by 6. So my x is 6. So that means this is 6, which means this is 12. Okay, so draw your figures. Everybody with me? Did I go too fast on that?
I got lost on 45.
Okay, 45. How long is each side of an equilateral triangle? Equilateral means all three sides are exactly the same. So, if there's three sides that are exactly the same, we take the perimeter and we divide it by 3. Because they're all the same. And if you need it, watch. So, all of these are the same. X, X, X. Because we don't know any of the sides. So, what is it? 76 equals 3x? Or 78? I don't know what it says. 78? And then you solve for x. You can always draw the picture, because if we don't know it, what do we put in its place? A variable. 49. Find the diameter of a circle with a circumference of 110. These I absolutely want to do. Diameter of a circle with 110. So circumference equals pi d. We know the circumference is 110 equals pi d. We divide both sides by pi. Right? So get your calculator. What did I tell you I want you to use for pi?
3.14.
So take 110 divided by 3.14. What?
110 divided by 3.14?
Mm-hmm. 35, you said.
Yeah. 35.03184.
35 centimeters. With me? Is that hard? Okay. Then 51. A circular track has a radius. So watch this. Circular track. Radius of 200, and is it feet? So I'm drawing it. What is the circumference of the track in yards? Ooh. This is an ACT type question. It's in feet. We want it in yards. So, first off, we're going to find the circumference. 2 pi r. Circumference equals 2 multiplied by 3 1400ths multiplied by 200. So that gives me C equals, what is that? I don't know. Somebody get me that.
What? No.
So do 2 times 3.14 times 200. That's 2 pi r. That's how we find circumference.
2 times
3 1400ths times 200. Ella, I know you have it. What is it?
It's 1,256 feet.
Feet. Now, how do we get feet to yards? Mr. Football Player, how many feet are in a yard?
I want to say 3.
Absolutely. So how do we go from this to yards?
We divide it by 3.
Beautiful. That gives me 4, 1, 26, is that right? 26, so it goes in 400, oh man, why am I struggling? 7, 8 times, 418-ish. So approximately 418 yards. Questions on how I do that? How are we doing?
Good.
Okay. Everybody ready? Can we move? May I erase this?
Yeah, can I finish?
Can you wait until I get done teaching?
Yeah.
I mean, I know that it's going to be a long class, but I've only got you until 12:15. I need 20 minutes. Can you give me 15?
Yeah.
Okay. Multi-step problems like that, where you have to solve and then think about it, are all ACT type questions. Where you just are given like an equation and said, do this. That is not an ACT type question. Okay. 3D figures are called solids. Ding dong. This is a 3-dimensional figure. Okay? We would call this a rectangular prism. We have the surface of the solid. Yes, ma'am. We're gonna get there. The surface is the outside of a solid, okay? The solids that we're gonna talk about are prisms, cones, pyramids, and spheres. Let's talk about sphere first, okay? So let's talk about spheres first. The definition in here is the set of all points in space that are a given distance from a point, the sphere's center. Any segment from the center to a point on the sphere is a radius of the sphere. Okay, so I don't care as much about the definition. Give me an example of a sphere.
Bouncy ball.
Bouncy ball, basketball. My go-to is a basketball. Can everybody envision a basketball in their mind? Okay. Here's how we draw a sphere. We draw a circle. Draw a little smiley face on the circle. And do the exact opposite with a dotted line. And then put a point in the middle. That's the center. Okay? This is the radius. A sphere always has a radius, just like a circle has a radius. Anywhere to the outside edge of that basketball. So somewhere in the middle of the air of your basketball to the edge is a radius. Okay? We're not going on the surface of the sphere. We're going from the center, which is in the middle, to the outside. Okay? So imagine me holding the basketball. My nose is the center. That's the radius. My nose is the center. That's the radius. I'm not saying the radius is around the edge of the sphere. It's from the middle, like this, the basketball can almost fit on my head, right? To the edge is the radius. Everybody with me? Okay. Questions on that? Okay. A cone. Circle as a base. Now, when we talk about base, a base in the simplest of ways is the bottom. Okay? May I steal this? Would that be all right? I'm going to take this off. Is that all right?
Yeah.
Okay. What's the base of this cylinder?
The bottom.
Bottom.
What is it? What shape?
Oh, the
Circle.
It's a circle.
It's supposed to be the top of it.
Ah, very good. The top and the bottom of this are circles. Okay. Now, a cone only has one base. And it also has a radius. Okay?
The radius is like at the bottom, I think. Yeah.
Yep. The radius is always going to be in that circle. Now, a cylinder two congruent circular bases. What do I mean when I say congruent? That they're what?
The same.
Exactly the same. Okay? Now, so far, everything that we've talked about consists of what shape? What do all three of these consist of?
Circles.
Circles. They have curves in them. Go back to yesterday. We had what we called polygons. Could polygons have a curve?
No.
No. So these are solids. These are three-dimensional figures. But three-dimensional figures have non-polyhedrons and polyhedrons. Polyhedrons do not have curves. And this comes down to Esther's question of, hey, Mr. H, what's a prism? And I'm glad you asked. Okay? Sphere, cone, cylinder. All have radii. There's a height for a cone. And then we also have a lateral height, but you don't need any of that. We'll get to that later. But really, they're all formed by circles. Okay?
Isn't there a height for a cylinder?
No.
Why don't
Well, there is. That's why there's an H already there.
Ah.
Okay? We good there? I thought you were saying sphere. Okay? So, polyhedrons are formed by what? What do you think if we have polygons which had no curves, what are polyhedrons formed of?
Curves.
Straight lines.
Yeah. Polyhedrons made only from polygons. And what are our polygons? Triangles, quadrilaterals, pentagons, hexagons, heptagons, octagons, right? Nonagons, decagons, dodecagons, different sided figures. There are two different, for our purposes, polyhedrons. There are prisms made from polygons with two congruent bases.
Isn't that
So-
a 3D rectangle? 3D rectangle?
What?
3D rectangle, basically?
Sure, yeah, like that tissue box. Okay? So a prism is made from polygons with two congruent bases. We name figures based off of their base.
Couldn't a cube be part of this too, or no?
So, how would we name this? Well, notice how you have a base down here, and you have a base up here. What are the shapes of the base? What are those shapes? Of this part and this part, what are they?
The rectangles?
Yeah. This is called a rectangular prism because those two rectangles are exactly the same. They are congruent. Now this one's a little bit trickier. No. Okay. When we look at this, what two things are exactly the same?
They're polygons?
Which two figures are exactly the same in that shape?
Both in the sides.
What are those called? What shape is it?
Triangle.
Oh, the triangles. So even though, wait a minute, Mr. H. Even though these aren't the bottom, the triangles are what are congruent. Therefore, how would I name this? If the bases we know are those two congruent things, how would I name this? A triangular what?
Prism?
Prism. Okay. Even though it's resting on a rectangle, there's no congruent side to that. And it has to be exactly opposite. Okay?
What's the other polyhedron?
What? What'd you say?
Oh.
Okay, so We have prisms, and we have pyramids. Pyramids, polygon base with faces coming to a single vertex. So the faces are the sides. You have bases, and then you have faces. Faces are the sides that aren't the bases. Okay? We name pyramids by their base, and I'm bad at pyramids, so I'm going to try my best here. Not bad, Mr. H. Look at that. Look at that. That's a pyramid, y'all. Woo woo! I'm bad at drawing. This is a rectangular pyramid. We have a base, which is a rectangle. And then how many faces do we have?
3 or 4.
We have 4, because there's 4 sides. We have a base here, we have a base here, which leaves me 1, 2, 3, 4 sides there. We have a base here, we have a base here. It's a triangle, which leaves me 1, 2, 3 faces on that one. Okay, now, let's say I called it a regular rectangular, a regular quadrilateral pyramid. What would that mean if it's regular?
All sides are the same, or all faces are the same.
All faces, everything's the same. So usually we use this for polygons, but it doesn't have to be. So this, let's see if I can do this. Cubes I feel like I screwed something up, but
Little off.
Oh, it looks like.
Little off on one side.
I did something wrong there. That's all right. Oh, that's why. This is supposed to be dashed. So is this. Okay. That is a cube. Okay, because, so we call it a regular regular quadrilateral prism. But if it's regular, that means all the sides are the same, so we can call it a cube. Now, jump to page in your textbook, page 41. It says classifying, oh, bless you, classifying polyhedra.
Good lord.
If it has 4 faces, it's called a tetrahedron. The number of faces is how you would name it. So this would be a hexahedron. 6 faces, or not, we're talking about faces. So faces, I'm sorry. So this would be a tetrahedron, even though it's a rectangular prism. I'm not going to care about the number of faces. That chart you can use as reference, but I'm not as important by it, okay? So you're gonna have time to work. We're done here in, 5 minutes. I might adjust the homework. The homework, yeah, I'm definitely going to adjust the homework. And I'll change it in here. So the homework says that I want you doing 1 through 37 off, and that is absolutely not going to happen. I would like you to do page 43. Nope. Here we go. Let's do changing this. Let's do page 42 through 44, I think. We're going to do numbers 1 through 3, numbers 9 through 13, and numbers 21 through 25. Okay, so not a lot. Give it a try. If you get stuck, let me know. If you need help, let me know. Some of you owe me homework from before.
From
Get
when?
some. From today.
Oh, I guess.
Good luck.